Good morning. I want to, first of all, thank you all for working on the volumes. I guess it looks like most of you have done a very good job or are almost done with it. Anywho, what I want us to do is work on what's called integration by partial fractions. It sounds like a big complicated topic, but it's actually a pretty easy one. And as we've talked about, working on our algebra skills is kind of key. So there's going to be two quick videos. One's going to be a reminder, and then the next video is going to be how to actually do the technique. So anywho, first of all, remember that the integral of 1 over x is the ln of the absolute value of x plus c. You can kind of think about that as by definition for now if you want. We learned this, where the derivative of ln of x was 1 over x, and that made sense. And then we also kind of talked about, at one point, why this isn't just an easy integral, because some of you might be thinking that we can rewrite this as, the integral of x to the minus 1 dx, right? Which would make sense, but then when we start to try to integrate this, we would raise this up, so that would become x to the 0, and then we got to multiply by the reciprocal of this, and then we do the plus c, and well, we know that this part here would just be 1, and then we're dividing by 0, so it's all bad news. Like, you can't do it this way. And that's why this integral is, or not why that integral is ln of x, but why it's not as straightforward as all of our multiplication rules. Anyway, I want to just show you a quick example of how to do this if it's just a linear equation in the denominator. We remember that a linear equation is like mx plus b, and let's change that to like 5 times 3x plus 2 dx. So we have a constant in the top, in the numerator. We have a constant. And in the denominator, we have a linear equation. Anytime that we have a situation like this, this technique works. So we're going to use u substitution. We're going to say that u is the denominator, 3x plus 2. I know we normally say we peel off a layer. If you would like to think about it like peeling off a layer, remember that this 3x plus 2 is really 3x plus 2 raised to the negative 1. And so we're really peeling off that negative 1. So then we're end up with that. And then we remember that the next step is to take the derivative. So we say du equals 3 bx. It is that simple. And then we have to now substitute back in. So the integral sign stays the same. I need a d. Well, there is no 3 here, right? It's a 5. So I'm going to rewrite this and say it's 1/3 du is dx. So I'm going to say 1/3 du, right? That's my dx, right? Takes care of that. And then this 5 is just going to come down because it's right there. And then 3x plus 2 is going to be right there. Well, I'm sorry, 3x plus 2 is u. My goodness. My penmanship this morning is pretty bad. But anyway, we have it. This is just a constant. It's 5/3. So if I really want to, I can rewrite this integral as 5/3 1 over u du. And based off of this up here, I know that this integral, 5/3, that carries out times that. ln of the absolute value of u plus c. And then I have to go back and plug it. 5/3 times ln u is 3x plus 2 plus 2. And there we have it. Yeah, I guess I'm going to do this, and maybe I'll do 2 more examples on a second video just to give to you guys. Okay?